Number 57. A pulley with a rotational inertia of 1 multiplied 10 power minus 3 kilogram meter square about its axle and a radius of 10 centimeter is acted on by a force applied tangentially at its rim. The force magnitude varies in time as F, which is equal to 0.5 t plus 0.3 t square, with F is in Newton and T in seconds. The pulley is initially at rest at a time t equal to 3 seconds. What is its angular acceleration and what is its angular speed? So we have to find the value of alpha. We have to find the answer for omega. First of all, let's write the given first. So what is given in the question? The moment of inertia value I is given here as 1 multiply 10 power minus 3 kilogram meter square. So this pulley has the radius r, which is equal to 10 centimeter, in terms of meter 0.1 meter. So the pulley moment of inertia, the rotation inertia is given as 1 multiply 10 power minus 3, and its radius, the pulley radius is given as 10 centimeter, so which is in terms of meter 0.1 meter. And also the force applied is given in terms of time, so F, which is equal to 0.5 t plus 0.3 t square. Initially the pulley at rest, that means it is at rest, so we have to find its angular acceleration at a time t equal to 3 seconds, and also we have to find its angular speed at time t equal to 0. So it has two time interval, time t1 which is equal to 0, time t2 which is equal to 3 seconds. Clear? So first of all, let's frame the formula. We have to find the answer for the angular acceleration. Once we find, we will substitute the value. Clear? So for that, what I am going to do, we have to use the formula for the relation between the torque tau as well as the angular acceleration. So torque tau, which is equal to moment of inertia I multiplied by alpha. Clear? For finding the answer for the angular acceleration, so because in the first question, let's write alpha value we have to find, and then B part we have to find the angular speed. Clear? Okay. So now I have to use this relation tau, which is equal to I alpha. Therefore, alpha, which is equal to tau divided by I. Clear? And in theory, we studied torque tau, which is equal to RF sine theta. Here, exactly when you have the pulley, you can see its radius. If you see the pulley, this is the radius and then this is the tangential speed. So the angle between the radius as well as the speed is 90 degrees. So sine of 90 degree, which is equal to Z1. So anything multiplied by 1 is 1. So in place of torque tau, I can substitute RF, because here theta is 90. So this is speed, this is R. Clear? Now I am going to substitute the formula for the torque here. So RF sine theta, sine of 90 degree becomes 1. So RF divided by I. So better I can make a caps R here. So caps R multiplied by F divided by I. So now R value is given, which is 10 centimeter, which is equal to 0.1 meter. So 0.1 multiplied with the force equation is given here as 0.5 t. So 0.5 t plus 0.3 t square divided by the moment of inertia value is given here as 1 multiply 10 power minus 3. This value already gave in the question, right? So I just simply substitute the values in this formula. Now what I'm going to do, I'm going to multiply 0.1 inside. So if you multiply, what we get? We will get 0.05 t plus 0.03 t square divided by 1 multiply 10 power minus 3. Now I'm going to split this into two parts. 0.05 t divided by 1 multiply 10 power minus 3 plus 0.03 t square divided by 1 multiply 10 power minus 3. Now, when you just divide 0.051 multiply 10 power minus 3, we will get 50, right? So 50 t plus 30 t square, which is nothing but our angular acceleration, and its unit is rad per second square. Now, still the problem is not completed. We have to find the answer for time t equal to 3 seconds. So alpha at a time t equal to 3 seconds, what we have to do, we have to substitute the value of t as 3 seconds in this equation. So we have to substitute t equal to 3 seconds. Wherever you have t terms, you have to substitute 3 seconds there. So let's substitute. So 50 multiplied by 3 plus 30 multiplied by 3 square. So what you will get, when you simplify this part, I got 420 rad per second square. So this is the answer for the first part. Now in the second part, we have to find the angular speed omega. So if you want to find the angular speed, we already have the equation for alpha, right? So for the B part, we have to use the formula to find the angular speed. To find angular speed omega, what we have to do, we have to use the formula for instantaneous angular acceleration, which is given by the rule alpha, which is equal to d omega over dt. So I have to rearrange this equation in terms of d omega. Therefore, d omega, which is equal to alpha multiplied by dt, right? Now, what I'm going to do, I'm going to integrate. So the equation for alpha is already we found here as 50t plus 30t squared. So in place of alpha, I have to substitute this one. So let's substitute d omega, which is equal to 50t plus 30t square multiplied by dt. So if you want to find the angular speed, we have to integrate the term both the left hand side and right hand side. When you integrate this d omega, we will get angular speed omega. And here we have two limits, the lower limit and the upper limit, right? So here the lower limit of the time is 0 second and the upper limit here is nothing but 3 seconds, right? So we have to write, so better I can split into two parts. So 50t multiplied by dt plus 0 to 3 is which is our limit of time, 30t multiplied by dt. So here we have to use the rule for x power n. So x power n, which is nothing but x power n is given by the rule x power n plus 1 over n plus 1. So I have to substitute, use this rule for the power of the t. So what is the power of the t here? Here is 1, here is t square, right? So we have 2 because I forgot to write 2 here. So 30t square. So let's apply this rule one by one. So better I can take the 50 outside because it's a constant. So 50, when I integrate this one, I got t square over 2 and the limit is 0, 3 plus likewise 30 I can take it outside. When I apply this rule for power of the t2, so I will get t cube over 3 and then limit is 0 to 3. Again, what I'm going to do, I can take the constant term outside. So I can take 2 outside. So 50 divided by 2 inside the bracket t square. So limit, lower limit is 0, upper limit is 3. Likewise here 30 divided by 3, I can take it outside. So for t cube, I have to substitute the lower limit and the upper limit. So let's substitute the value for the lower limit and the upper limit. So what we will get, 50 divided by 2, which is nothing but 25. So 25, and then in place of t, I have to use the upper limit, which is 3 square minus the lower limit is 0 square, right? Plus, when you simplify this, we will get 10, and likewise substitute the upper limit and the lower limit, we will get 3 cube minus 0 cube. So 25 multiplied by 9, because 3 square is 9, right? So likewise 3 power 3, which is nothing but 27, So plus 10 multiplied by 27. So here 25 multiplied by 9, I got 225, 225, and 10 multiplied by 27, which is 270. So 270 plus 225, I got the answer here as omega, which is equal to 495 rad per second. This is the answer for the second part. That's it. Thank you.